Hello everyone and welcome to this video. In this part, the fifth part of the end of term coverage for mathematics, we will discuss the unit that is specialized around the binomial theorem itself and mathematical induction. It's going to be quite easy, not a very long video, it's a short concept. And again, if you feel confident, please skip to the second part of the video where we solve questions. So let's start. So again, we'll talk about the binomial theorem and induction. So what does the binomial theorem state? So if we have, for example, a plus b raised to the power of n, it is not equal at all to a to the power of n plus b to the power of n. This is just extremely wrong. However, it is equal to something else. So if we have again a plus b raised to the power of n, it is equal to n c0 times a to the power of n, and then plus n c1 times a to the power of n minus 1 b to the power of 1. And here, of course, we have a b, but it is raised to a power of 0. And then let's continue. It is plus nc2 a n minus, not 1 in this case, but 2, and then b to the power of 2, and so on and so on and so on, where we reach a point where we have n c n times a to the power of 0 and b to the power of n. This is the binomial theorem. Now it seems very complex, hard to understand, and out of this world, but it is really simple. Let's take an example. So let's take this case. We have a plus b to the power of 2. This is extremely simple. We know the result. It's a squared plus 2ab plus b squared. But where did we get it from? Right? Because we learned it, but we did not learn some sort of proof. We can use the binomial theorem to prove this. So let's do it. So if we have a plus b squared, we will start by 2c0 times a to the power of n, which is 2. So a squared, and then we have b to the power of 0, which is 1, plus 2c1 times a to the power of 2 minus 1, b to the power of 1. Now 2 minus 1 is just 1, right? So a to the power of 1 times b to the power of 1. And then plus 2c2 a to the power of 0, b to the power of 2. So just b to the power of 2. But what is this c exactly? It's actually called combinations. And combinations are easily found using your calculator, right? And there is an equation for it, but I don't think it's important to get to it because it will be confusing a little bit. So the way we find c in our calculator is using shift and then divide. So let me write this in the calculator. I will write 2, and then I will press shift and then the divide button, and then I will put 0. And what do we get for this? We actually get 1. So this is 1. And then I will just write a squared again. Plus, let me write 2c1. What will I get? I will get 2. And then a to the power of 1. And then b to the power of 1 itself. Rather, let me change the color. I think it would be better. So 2, and then b to the power of 1, or not b, but a to the power of 1, b to the power of 1, which is just ab. Plus, let me put 2c2. What will I get? I will also get 1. So 1 times b squared. And what is this equal to? A squared plus 2ab plus b squared. And isn't this formula that we learned before? This is how it really comes from. And now let's move into something else. Let's not use the power of 2, it's just too easy. Let's go to the power of 4, for example. So if we have a plus b to the power of 4, how do we solve it? Let's do it again. It's going to be equal to n c 0 at first, but what is our n? It is just 4, so 4c 0, and then we will have a to the power of 4, and then plus 4c1 times a to the power of 4 minus 1, which is just 3, and then b to the power of 1, plus 4c2 a to the power of 2, b to the power of 2, plus 4c3, and then a to the power of 1, b to the power of 3, and then plus 4c4, and then I will have b to the power of 4. Let's simplify it. So what is 4c0? It is equal to 1 times a to the power of 4, plus what is 4c1? Which is equal to 4. So we'll have 4 times a cubed b to the power of 1, plus what is 4c2? It's equal to 6, using the calculator, of course. So 6 times a squared b squared, and then plus what is 4c3? It's equal to 4 times a power of 1 b cubed, and then what is 4c4? It is equal to 1, so I will write 1 here, and then b to the power of 4. And this is our answer. Let's actually simplify it first before highlighting it. So it's going to be a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus b to the power of 4. This is our complete and final answer. Now I bet you probably remembered some sort of triangle, and yes, indeed, it is the Pascal's triangle. And what is it exactly? For those who don't know, it starts with a 1, and this is n to the power of 0, and then we have 1, 1, that's n to the power of 1, and then we have 1 times the sum of these two, plus 1, this is n to the power of 2, and then we have 1, 3, 3, 1, and then 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1, and so on and so on and so on for different powers. So this is n power 3, n 4, and n to the power of 5. So this is exactly Pascal's triangle, and for each value of n, you will get a coefficient that is similar to these. So let's take an example. If we have x plus y to the power of 7, and we are told to find, for example, maybe fifth term. How do we do it? The first step is define a variable, for example, k. And k is equal to the term itself minus 1. So k is equal to 5 minus 1, which is 4. So this is what we are going to use. The second step is write nck, right? So we'll write 7, because 7 is n, times c times k, which is 4. Let me actually change the color so it's clearer for you. So I'll write n, which is 7, times c times k, which is 4. Alright? And we will find the result for it using, of course, our beloved calculator. So 7c4, and it's equal to 35. And then the third step, the final step, is to do something like this. So we know that x decreases in power as we move on, and y increases by power. But how much will x decrease and how much will y decrease? So we will do this. We will take the x, and since it starts by the power here, it starts by 7, it starts by n, we will minus k. And then y will have an increase of k. It will have k, basically. So we will have x to the power of 7 minus 4 times y to the power of 4. Okay? And this is, of course, equal to x to the power of 3, y to the power of 4. The final step, which I will write right here, is combining these two, combining this and this. So the final answer is going to be 35 times x to the power of 3 and y to the power of 4, and this is the fifth term of this binomial. Now about mathematical induction, it's extremely easy. We will just have an example later, but the only thing that will really come in the final exam is finding the counterexample. And to find the counterexample, you just have to take some tests. You will take some numbers, you will test them to see if the theorem that you have is true or not. We will take an example about it. So let's solve this question. Find the fifth term of y plus z to the power of 11. Again, the first step is defining what k is. K is going to be the term that we want minus 1. So 5 minus 1, which is equal to 4. And then this is the first step, of course. The second step will be to find the coefficient, or not the coefficient, but the constant that we will have. And it is going to be nck, where n is equal to 11, of course, and k is equal to 4. So we will have 11c4, which is equal to, according to the calculator, to 330. And then the third step is to have the first term, y to the power of n minus k, and then z to the power of k itself. So y to the power of 11 minus 4 and z to the power of 4, which is equal to y to the power of 7, z to the power of 4. And then the final amazing step is to put these together. So the answer is 330 y to the power of 7, z to the power of 4. And this is our answer. This question will have the exact 3 steps. The first step is to find k, and k is equal to the term that we want to find, minus 1. So it's 6 minus 1, which is equal to 5. And then the second step is to find the constant. That's going to be nck, which is 10. Let me just make it an arrow because they are not equal. So 10c5. And according to the calculator, it is equal to 252. Right? And let me remind you how to find it using the calculator. You just press shift and then divide. So 252. And then for the third step is finding what c and d are going to look like. So it's going to be c to the power of n minus k, and then d to the power of k. So c to the power of 10 minus 5, and then d to the power of 5, which is equal to c power 5 and d also to the power of 5. And then the final amazing step is combining these two. So it's going to be 252 c power 5 d to the power of 5. And this is our answer. And here to find the counterexample to disprove this kind of expression, what we'll have to do is take test numbers to see if really this is true or not. Of course, because the exam is going to be multiple choice, you just test the numbers that are given. So let's test the numbers. So I will test, for example, n is equal to 1. So let's do it. We'll have 3 to the power of 1 plus 1, which is equal to 4. Is 4 divisible by 4? Yes, it is divisible. So this is not a counter example. No counter example. Let's try n is equal to 2. So we'll have 3 to the power of 2 plus 1, which is equal to 9 plus 1, which is 10. 10 is not divisible by 4. We cannot divide it by 4. So yes, this is our counter example. N is equal to 2 is counter example. It's that easy. This question is just a little bit more interesting because you will have to do something a little bit more. So let's do it. So we will have to disprove that any number added to its predecessor numbers is not equal to that number squared. For example, let's try 1. So for example, n is equal to 1. So we will only have 1. And is 1 equal to 1 squared? Yes, it is equal to 1 squared. So this is not counter example. If you don't understand this, you will understand from the second number. So not counter example. Let's try n is equal to 2. And in this case, we will not just write 2, but we'll write 1 plus 2. 1 plus 2. So is 1 plus 2 equal to 2 squared? Is this the case? No, it is not the case. So this is disproved. So is this correct? No, it is not correct. Therefore, the n is equal to 2 is a counterexample that really disproves this equation that we have. Let's try 3. Let's try n is equal to 3. We already found an answer, but let's find another one. So 1 plus 2 plus 3. Is it equal to 3 squared? No, because this is equal to 6 and this is equal to 9. And they are not equal. Therefore, 3 is also counterexample. And all the other numbers, I assume, are also counterexamples. So we have 2, we have 3, and also 4, I think, is going to be a counterexample, maybe, and so on and so on. And this is it for this revision. I hope you find it interesting and helpful. If you have any questions, feel free to contact anytime. Thank you very much.